Okay, hello, here's your warm-up. Have you ever been on an actual seesaw? What happens if you get on with someone that's bigger than you, smaller than you, or exactly the same size? Which situation would make the seesaw level? All right, so go ahead and hit pause, answer this in your notebook, and then press play. All right, so if you get on with someone that is bigger than you, you're going to actually be what's going on in this picture. This boy's a little bit bigger, and this boy's a little bit smaller, because if you weigh more, you're going to push down on the seesaw. So vice versa, this boy's a little bit heavier, so he's on the down part of the seesaw. If these little boys weighed exactly the same amount, their seesaw would be completely level. That means that whatever weight's on this side would be completely equal to whatever's on this side. Does everyone agree with that? All right, so let's go ahead and move on. All right, so your target today is to be able to solve 1- and 2-step equations by using pictures. So here's a little bit of notes I want you to write down before we get started today. Modeling equations. You don't have to write the 1-step because this works for all equations. So anytime we see a long rectangular box, that's going to be equal to a positive x. If you see a long rectangular box with a negative in it, that's going to be equal to negative x. If you see a small square, that's going to be a positive 1. If it has a negative sign in it, that's a negative 1. So the only other thing I want you to write down is this says, the only way to be finished with the problem is if you have the variable all alone. It doesn't matter what the variable is, and it doesn't matter what side it's on, as long as you get x equals something. It could even be on the other side, or it could be a y or a z or an r. It doesn't matter what the letter is or what side it's on. All that matters is that it is the only thing on that side of the equal sign. All right, so let's look at this. You guys are going to ignore these little boxes up here. Those are really for me. So I want you to draw this in your notebook, a big or long rectangle that has an X, and then a little square with a 1, equal sign, two little squares with 1s in them. So first it says rewrite the equation. So once you have it drawn, I want you to go ahead and press pause and write down what you think the math problem is, and then press play to see if you got it correct. All right, so what you should have had is that is an x, so that's x. And since we have two things on here, it's going to be plus 1. So if x plus 1 equals 1, 2. So that's it. That's what the math problem was, and this is how you would show it pictorially. Now, the way you would solve this is you want to get the letter by itself. So when I look, I say, okay, where is the letter? And it's right here. So I need to get rid of this other thing. So I need to get rid of this positive 1. But the whole idea with the seesaw is that both sides are equal. So if I get rid of something on one side, it's no longer equal. So in order to be able to keep this symbol here, I have to do the same thing on both sides of the equal sign. So if I want to get rid of a positive 1 here, I have to do the exact same thing on the other side in order to keep it equivalent. So what I do is I look to the other side and I say, do I have a positive 1 to get rid of? And I do. So what I can do is I can get rid of that positive 1 and this positive 1. So what I'm going to do now is just read what's left because I have the x by itself. So now I have x is equal to 1. So once I have the letter all by itself, which it is, that's my answer. So now I'm done with the problem. All right, so let's try this one. Go ahead and draw this picture in your notebook. So you have 3 big rectangles with x's equal negative 1, negative 1, negative, 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 negative. So go ahead and draw that, press pause, and I want you to try to write down what you think that math problem is. Once you've done that, go ahead and press play again. So what I see here is I see 1, 2, 3 x's. So that's really just 3 x's equals 1, 2, 3, 4, 5, 6, negative 6. So now I want to try to solve it. So I look over here where the letters are, and I think there's nothing else over here but x's. So there's nothing for me to get rid of. So now I have to sort of think about it. If I have 3 x's, I have to take whatever's on this side, and I have to break it up into how many groups? 1, 2, 3. 3 equal groups. So if I take these little squares and break them up into 3 equal groups, each one of these x's is going to get 2 of these boxes. So 1 positive x would be equal to -2 because these are negatives. All right, let's try this one. Once again, don't worry about this. So go ahead and draw this and then write down what you think the math problem is and go ahead and press play again on the video. All right, so on this side, I have 4 negatives and an x. So typically your variable is going to come first. So I have a positive x and I have 1, 2, 3, 4 negatives. So here's where you need to sort of learn this. Subtraction and negative are going to mean the same thing. So since I have a -4, I can just put -4 and that represents these 4 negatives. I am never going to write minus a negative. So I would not write that. This subtraction represents -4. And on this side it has 2 positives. So now I want to try to solve the picture. So if I need to get the x by itself, I look over here and I have 4 negatives to get rid of. So I check the other side. Do I have 4 negatives to get rid of? I don't. So I have to figure out, how can I put 4 negatives over here and not mess anything up, but still keep it equal? Because if I just add negatives, it's going to throw it off. So here's where you're going to write some notes. So the only thing you can add whoops, that should have said the only thing you can add are 0 pairs. Because zeros do not change the value of anything. I can keep adding 0 to everything and it doesn't really do anything to each side. So a 0 pair. The word pair means 2 and 0 means it has no value. So a 0 pair in this case is going to be, if I add a negative, I have to add a positive with it, because if you add a negative plus a positive, it's going to give you 0. So make sure you have all that copied down. You can press pause if you need to take a second. So if I need 4 negatives to get rid of, if I add 4 negatives, 1, 2, 3, 4, I'm just going to use circles because they're easier. I have to add 4 positives so that I don't change the value. Those are 0 pairs. So I have 1, 2, 3, 4, 0 pairs. But now I actually have 4 negatives to get rid of here, and I have 1, 2, 3, 4 negatives. So now on this side I have an x, and I know that that's equal to 1, 2, 3, 4, 5, 6, positive 6. So in this case, x equals 6. All right, so this one's a little bit different. All it has is a scale, but remember, if it's level, that just means it's equal. So draw this, write your math problem, and then try to solve it. So when I look at it, I have 2 x's. I have 2 positives, so I put +2 equals 6. Now, if I want to get the x's by themselves, I need to get rid of these 2 positives. So I come over here and I say, do I have 2 positives to get rid of? I do. So if 2 are gone here, 2 have to be gone here. So now I have 2 x's and I have 4 positives. So that means I have to take these 4 positives and to break them up into 2 equal groups. So each x gets 2 positives. So 1x is equal to +2. So this is your answer. All right, go ahead and try this one. Draw this picture, write the math problem, and then try to solve it. So when I look at it, I have 1, 2, 3 x's. Remember, x's typically come first in the equation. And I have 1, 2, 3. So +3 equals 1, 2, 3, 4, 5, 6. But they're negative, so -6. In order to get the x's by themselves, I need to get rid of these 3 positive ones. And when I look at this, I don't have 3 positives to get rid of. But I remember that I can add some things if I add a 0 pair. So if I add a positive, I have to add a negative along with it. So now I can get rid of 1, 2, 3 positives from both sides. And now I'm just going to count what's left. So I have 1, 2, 3. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to take these 9 negatives and split them up into 3 equal groups. So I sort of set it up pretty good so that I can see that 1x is going to get 3 negatives every single time. So x is equal to 3 negatives. All right, so when you draw this right here just represents negative. So when you write this math problem, after you've written it, go ahead and try to solve it. So this here, I have -2 x's, I have 1, 2, 3, 4 minus 4 because they're negative equals 2, positive 2. So in order to get the x's by themselves, I have to get rid of these 4 negatives. But do I have 4 negatives to get rid of on this side? I don't. But what I can do is in order to get 4 negatives, I have to add 4 positives along with it. So in this case, if those 4 negatives are gone, I'm going to get rid of 1, 2, 3, 4. And now I have negative 2, so I have 2 negative x's. And that's equal to 1, 2, 3, 4, 5, 6. So when I draw these, I'm going to split them up into 2 groups. So 1, 2, 3, 4, 5, 6. So each negative x gets 3 positives. So negative x would equal 3 positive. But I told you guys that in order to be done, you have to have x all by itself. And it's not, because I have a negative sign here. So I have to figure out, how do I get rid of that? What would I have to do to this in order to get rid of the negative? I could flip the sign, right, or just make it the opposite. So the opposite of negative x would be positive x. And the other rule I said is whatever I do to one side, I have to do the other side. So if I change the sign of this negative x to positive x, I have to change the sign of this positive 3, and it would become a negative 3. Now I have x all by itself, and I have my answer. X is equal to negative 3. All right, go ahead and try this one. So once again, that's a negative. So you have negative x minus 1 equals positive 9. So we want to get the x by itself, so we need to get rid of this negative 1, and we have none, so we add a 0 pair. Negative and a positive. Now we can get rid of it. So that negative and that negative are gone, and what we have left is 1 negative x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't forget the one you added. But am I finished? Is this x all by itself? It's not. I need to get rid of that negative sign. So if I flip the sign or make it the opposite, that would become positive. Whatever I do here, I have to do here. So positive 10 would become negative 10. And all I did is whatever I did here, I did to the other side. All right, so that's the end of the video. Hopefully that helps you guys. If you need to rewatch it, go ahead and rewatch it and take some notes.